In this video, we are covering how to calibrate external axes using our RobotMeta Pro Pendant. We will be using a P2 positioner which has two external axes. In this case, our first external axis, which is also our seventh axis, aka J7, will be used to tilt the tabletop back and forth along the y-axis. A left-hand thumb rule will be used to determine which direction is positive and which way is negative. Our second external axis, which is also our eighth axis, aka J8, will be used to rotate the tabletop along the z-axis. A left-hand thumb rule will be also used to determine which direction is positive and which direction is negative. We start off by verifying that we have the correct velocity configurations, the right gear ratio and link length settings. Under J7 and J8 servo configuration, we have the option to reverse direction, set encoder resolution, and then we have soft limit configuration, which can set the soft limits on each axis. Under match servo, the first three stations are used for 6 axes on the robot, and station 4 will match the servo drive. And station 4, we will match the servo drive for J7, and station 5, we input the servo drive for J8. Over here at joints mapping on joint 7, we define that station 4 will be responsible for controlling joint 7, and station 5 will be responsible for controlling joint 8. In this case, both of them are single axis servo drive, which you see there's a number 1 next to the station number. If you are setting your positioner up for the first time, after you change the match servo and joint mapping settings, you will need to restart the PLC and servo drives for the change to become effective. After calibrating, you will first click into the home position, set your J7 and J8 home position. Now we go to setting external axes. COORD chord stands for index, which is the number of positioners. Currently, we support up to 3 positioners. Since we have a 2-axis positioner, we are selecting multi-axes. For our coordination axes, we are defining J7 as C1 and J8 as C2. We then proceed to calibrate coordination number 1 C1 axis. The specified points I'm using in this video is across the IP mark on the tabletop. First, we rotate J7 to an angle less than -30 degrees. Adjust the torch gun angle. Keep in mind that after the adjustment, you cannot rotate the gun angle, TCP, until the calibration is completed. You are only allowed to move the TCP on a Cartesian, also known as world coordinate, along the XYZ directions. Then we move the TCP to the specified points and record the first points P1. The pendants will show a prompt that P1 has been successfully saved. For P2, we are rotating J7 towards the positive direction. The key is to ensure the difference of joint coordinate of J7 between this new position and previous position is greater than 30 degrees. Then we move the TCP to the specified point and record the second points P2. For P3 again, we are rotating J7 towards the positive direction. The key again is to ensure the difference of joint coordinates of J7 between this new position and previous position is also greater than 30 degrees. Then we move the TCP to the specified points again and record the third points P3. After that, we click Calculate. The pendants will show a prompt that this external axis has been calibrated successfully. We now proceed to calibrate coordination number 2 C2 axis. We are using the same specified points, which is across the paint mark on the tabletop. First, we brought J7 back to home position, adjust the torch gun angle. Again, keep in mind that after the adjustment, you cannot rotate the gun angle TCP until the calibration is completed. You are only allowed to move the TCP on the Cartesian coordinates along the X, Y, Z directions. Then we repeat the same steps to calibrate. First, we rotate J8 to an angle less than negative 30 degrees. Then we move the TCP to the specified points and record the first point P1. The pendant will show a prompt that P1 has been saved successfully. For P2, we are rotating J8 towards the positive direction. The key is to ensure the difference of joint coordinate J8 between this new position and previous position is greater than 30 degrees. Then we move the TCP to the specified points and record the second point P2. For P3 again, we are rotating J8 towards the positive direction. The key is to ensure the difference of joint coordinate of J8 between this new position and previous position is also greater than 30 degrees. Then we move the TCP to the specified points and record the third point P3. After that, we click Calculate. The pendants will show a prompt that this external axis has been calibrated successfully. And now our two external axes P2 positioner has been calibrated. We now go to the bottom left, select CRD coordinates, and select positioner 1 in this case. Trigger and hold Enable. Select coordinate axes on top right. First verify by rotating the C2 axes. Next, verify by rotating C1 axis. And last, we verify C2 again at a tilted angle. Up next, we are going to demonstrate how to reverse directions of our external axes. To reverse your external axes, you'll go to your servo drive, press M twice to get to PN000. Then long press S and press the up arrow to change bit 0 from 0 to 1. Last, press M to exit. Then we repeat the same steps for the JA external axes. After it's done, we need to restart both the servo drives and the robot PLC for the changes to become effective. After restarting the machine, we now proceed to verify the directions have been reversed successfully. Then we're going to repeat the same steps that we previously mentioned in this video to calibrate the external axes. Again, the key is that P1 has a joint coordinate that's less than negative 30 degrees, and P2 and P3 are 30 degrees greater than the previous points.